Hello, everyone. Welcome to this webinar on Texas drought conditions. My name is Joel Lisenby, and I'm the Regional Drought Information Coordinator at NOAA's National Integrated Drought Information System, or NIDIS. I'm also at CERES, which is hosted at the University of Colorado. If you're not familiar with NIDIS, you can learn more about this program at drought.gov, which I highly encourage heading over to drought.gov and seeing all of the resources and data that we have there. Before we get started, I'm going to cover just some quick webinar logistics. For this webinar, everyone is muted and the webinar is being recorded. The webinar recording will be available from the NIDIS YouTube channel and at drought.gov/webinars. That will probably be up tomorrow or the next day. And there will also be a follow-up email later with a link to that recording. The format for today's webinar will be a presentation by each of our invited speakers, followed by a time for questions for both of them at the end. If you would like to ask a question, you may do so at any time by typing it into the questions box and go to webinar, and I'll be moderating the questions when we get to the end. I'm honored to welcome and introduce our two speakers today. First is Dr. John Nielsen-Gammon. Dr. Nielsen-Gammon is a Regents Professor of Atmospheric Sciences at Texas A&M University. His research includes extreme rainfall, drought monitoring, climate data quality, and computer modeling. John's also the State Climatologist for Texas and has held that position for the past 20+ years. On top of that, Dr. Nielsen-Gammon was recently appointed as the director of the Southern Regional Climate Center. So he's a very busy guy, and thank you for taking some time with us today. John, following John, we'll be hearing from Victor Murphy. Victor is the Climate Services Program Manager for the National Weather Service for the Southern region, which includes the state of Texas. He routinely participates in drought monitoring and the issuance of climate products from the various National Weather Service forecast offices across Texas. So a big thank you to Victor for joining us today too. And with that, I'll pass over to you, John.
Okay, thank you very much. So I'm going to cover basically how we got here and what the current status is of drought across the state of Texas. And then Victor is going to look at what's coming down the pike, or at least what we think is coming down the pike anyhow, based on the latest information we have. Over the past week, we had decent amounts of rain in parts of the state of Texas, which sort of changed the drought picture a bit. The next slide shows the precipitation over the past week. And most of the eastern part of the state received at least a ½ inch of rain. Some places received 3 or more inches of rain. There were also some fairly intense thunderstorms around the lower Pecos River area, but much of West Texas, as well as parts of the coastal bend, remained quite dry. Unfortunately, remaining quite dry has been a common theme for this winter. The next slide shows the pattern of precipitation over the past month, and despite all that rainfall we saw during the last few days, the majority of the state is still at below normal rainfall totals for the month, indicated by the yellow and red colors on the map. The places that are doing relatively well recently are basically 2 counties depth along the Red River in the central and eastern border with Oklahoma, as well as other parts of central part of East Texas and the locations I highlighted before. But what this really highlights is also the areas in dark red, which have received generally no precipitation, or at least less than 5% of the normal for the month, which includes large swaths of the western part of the state, as well as some isolated areas in other portions of the state. Now, this particular drought did not begin this month, obviously. Next slide shows the percent of normal precipitation basically since the beginning of September. And here we see almost none of the state with above normal rainfall over that period. Most of the state received less than 3/4 of its normal amount. About a third of the state, or maybe 40%, have received less than half of its normal amount, and large portions of West Texas, highlighted in bright red, have received less than a quarter of their normal amount of precipitation, which would make for a dry month. But when we're talking about 8 months, 2/3 of the year, that's a really serious drought. Now, rainfall is not the only thing that goes into drought. It's been relatively windy over the past month across Texas, which has enhanced evaporation when there's been water to evaporate. Temperatures are also a potential concern, particularly in this area where we're seeing long-term warming temperatures. The next slide shows the temperatures over that same 8-month period compared to, just the past 6 months, compared to normal. And across most of the state, it's been running about 1 to 2 degrees above normal. That actually hides quite a bit of variability. I'm sure y'all remember December of last year, where temperatures were in much of the state more than 10 degrees above normal. Conversely, February of this year was several degrees below normal for most of the state. Essentially, it's all averaged out to something close to what we would expect for a typical winter these days. Maybe a little bit cooler, because ordinarily when you're having La Nina, temperatures in the wintertime are not just dry, but also typically considerably warmer than normal. So to look at rainfall in a drought severity context, the next slide shows the 6-month assessment of overall precipitation and how that compares to typical historical conditions. This is using the US Drought Monitor conventions, where something that occurs less than 2% of the time would be characterized as exceptional drought. Something 5% of the time or worse would be extreme dryness, and so forth. And so we see on this particular time scale large swaths of the state that this particular index would highlight as being extreme to exceptional drought, and really very little of the state in normal or above normal conditions over this period. Okay, I mentioned La Nina as a contributing factor to this. Basically, in about 2 winters out of 3, Texas gets below normal precipitation during a La Nina. The next slide shows the temperatures in the tropical Pacific. Blue is where they're at least half a degree below normal, and the criterion for a La Nina is when conditions in the tropical Pacific are at least half a degree below normal for several months. Now, this is a large swath of ocean territory we're looking at. You can see part of Australia in the lower left. You can see part of Mexico and Central America in the upper right. And consequently, there's quite a large swath of the tropical Pacific along the equator where temperatures are still running more than half a degree below normal. And the next slide shows how those temperatures have evolved over time. I've highlighted an area in the second graph, which is basically the indicator we use to look at whether things get classified as an El Nino or La Nina. Blue shading is where temperatures are below normal. The gray shading is where it's at least half a degree below normal, which is the criterion for a La Nina. And what we see is we had basically neutral conditions last summer in June and July. Then beginning in October, temperatures crossed down below the minus half a degree threshold, and they persisted below that threshold for the past 6 months or so. That makes this basically a weak to moderate La Nina event under classical historical conditions. And Victor's going to take a closer look at La Nina and how that's projected to change going forward. I want to wrap up my view of drought status right now by looking at 3 stations across the state of Texas and how precipitation has evolved over the past several months, how it compares to the driest conditions in the historical record, and what the prospects of change are going forward, at least based on what's happened in the past. So, for example, here is Lubbock, Texas, from starting in September of last year and going forward through, well, through this summer. The green graph is the accumulated precipitation, and since September, Lubbock has received less than 2.5 inches of rain total. The black line is where obviously we don't have observations because that's the future. So maybe Victor will fill in that part of the graph. But in the meantime, the only really good thing about this is the dry periods occur during what is normally a relatively dry time of year for Lubbock. The brown graph you see on the same chart is the normal amount of precipitation from September 1st to whatever date is plotted. And the graph is fairly flat during December, January, February, meaning you normally get relatively little rainfall, but still, from December to March, you normally get about 2 inches of rain, and that's all we've gotten in the entire 8-month period. And the dryness really started in September, when usually we're topping off the summertime with decent amounts of rain and allowing us to get going with a winter wheat crop and get some soil moisture in the ground before temperatures are going to evaporate all that water. That didn't happen this year. The rain during the early part of the summer was really sucked out of the soil during the dry periods of September and October, and it's never come back, at least not for much of the high plains. The next slide compares this to the 5 driest September through present day on record. And what you see here is Lubbock, as of April 26, is having its driest September to present day period in its entire weather record, which goes back about 100 years or so, or more than that. And the previous driest periods, at least we can be optimistic about it, they all were close to or above normal going forward. Of course, they all turned around basically in mid to late April, and we haven't seen that happen this year, and the prospects for at least the remaining few days of this month are not good. So those dry years include a recent one, 2013 and 2014, which is probably the closest analog to what we've seen so far this year in the Lubbock area. But even at that, they'd had about 3¼ inches of rain since September 1st in 2013, 2014, whereas here we've had just barely over 2 inches. The next slide adds in what turns out to be the driest 12-month periods over this time, and the graph that really stands out on the bottom right is 2010, 2011. No surprise there, I think. It was really disastrous when basically almost no rain fell during the wet time of spring and summer in Lubbock. Lubbock area was generally doing better at this time of year in 2011 because they've gotten decent amounts of rain in September and October, almost normal for those 2-month periods. So good news is, well, the bad news is we're worse off now than we were in any previous year by this reckoning. The good news is it's still unlikely we'll stay so dry as what happened in 2010 and 2011, but of course there's no guarantees in that regard. Okay, next let's look at Waco, Texas. Parts of central Texas have been fairly dry for the past several months. Waco, since the middle of November, has only seen about 3¼ inches of rainfall, and normally Waco is getting pretty steady rain throughout the year. Normal would be 12 inches by this time, so they're running at only about 1/4 to 1/3 of their normal rainfall total since the mid-November. Next slide shows the driest periods in the historical record there, and this is not really a whole lot different from the driest ones overall through August, because unlike Lubbock, these other dry years didn't really recover. The ones that rival the present day are 1925 and 1953. 2010, 2011, again, is wetter than it was, than it has been this past few months. 2010, 2011 ended up being the wettest period through August on record. We'll see how this goes, but at least the 5 previous dry years up to this time did not turn out all that well. One of them had a nice recovery. Others pretty much stayed below normal for the rest of the year as well. Okay, finally, let's go all the way to the other corner of the state and look at Beaumont. Since the beginning of November, it's been quite a bit wetter than these other 2 stations we looked at. Almost 11 inches of rain since the beginning of November, which is nice. But normal this time of year is about 24 inches since the beginning of November. So they're running less than half of their normal amount. And if we compare that to the previous driest periods over the same interval on the next slide, what we see is its 3rd driest on record to date, with the driest being just slightly less than 10 inches. So they have unusually dry conditions. And for a place that's used to more than twice as much rainfall and fairly steady rainfall at that, this is something that is not generally expected for that area. Going forward, those previous 3 driest periods show quite a range of possible outcomes, from recovering to near normal to staying extremely dry during the drought of 1925. The nearest recent analog, I suppose, would be 2005, 2006, for those of you who remember what happened back then. And the next slide shows the distribution of the driest years on record, which are actually not a whole lot different from the ones we look at. 24, 25 was just super dry and the driest on record by a long shot. So, technically we're on track to have the driest year on record, but it would have to be quite a bit below normal going forward for that to happen. But even if we get near normal rainfall, it's still going to end up being one of the driest Novembers through August on record. We'd have to have quite a bit of rain to recover from that. So based on all of that, well, we've looked at the recent rainfall totals, but there are areas of the state that have actually been dry for even a longer period of time. The next slide shows drought on a 2-year time scale, and we see really quite dry conditions in the high plains and panhandle, the Trans-Pecos area, along the Rio Grande, down toward Laredo, and across the Winter Garden area, and also the hill country showing up as being fairly dry long-term as well. So that means that deeper rooted vegetation, it doesn't really have the moisture to draw upon. For newly planted crops, that doesn't really matter. The crops, the root depths are still fairly shallow, but for long-standing pastures, this dry period right now is added on top of what's been a prolonged period of dry conditions. So all of that leads to the current US Drought Monitor. This will be, next slide, this will be updated tomorrow with the rainfall from the past week. So we would expect to see improvements in the wettest areas, such as around Del Rio and down in South Texas. But we might actually have worsening conditions in other parts of the state that missed out on rain this past week. But at least as of now, we have over 15% of the state in exceptional drought and over half of the state in at least extreme drought conditions. So what this means going forward, let's go ahead and turn it over to Victor.
Thank you, John. Victor, I'm going to give you screen sharing permissions. It's taking just a second, but it should come through very soon. And while we're waiting for Victor to pull his slides up, I'd just like to remind everyone that if you have a question for John or Victor, go ahead and drop it into the questions box. And after Victor's presentation, we will have some time for questions. So Victor, we are seeing your slides, but it's not in presenter mode yet.
Yeah, I got you, Joel. Let me switch over here.
Sorry, what was that?
Yeah, let me switch over here. I'm sorry. Okay, is that better?
Looks great.
Super.
Take it away.
Okay, thank you for the introduction, Joel, and thank you, Dr. Nielsen-Gammon. My name is Victor Murphy. I'm the Climate Service Program Manager for the National Weather Service Southern Region Headquarters. And we've got about a dozen forecast offices that cover the state of Texas. I would encourage everyone, if you need more specific drought information for your area, to contact your local weather forecast office across Texas. So I'm going to do a quick sort of review of what we have to expect going forward. I think John laid the foundation really nicely, covered Lubbock area, Beaumont, Central Texas, and I'm going to take a quick tour around the state also. So as we know, Texas has tremendous variability with regards to yearly average rainfall. Parts of the state, like John pointed out, near Beaumont, get like 54, 55 inches of rainfall per year. So if they have 20 inches of rainfall or 25 in a year, that's a significant drought for them, less than 50% of normal rainfall. But conversely, if you get out roughly Central Texas westward, their average yearly rainfall is only 22 to 26 inches of rainfall, and obviously it drops off even more as you work your way westward. So tremendous variability. There's a real tight gradient here along the Central Texas, along the I-35 corridor. Pretty much, the Gulf of Mexico moisture tends to, be concentrated across the eastern third of the state. Thus, the increase in heavier rainfall totals on average. Gulf of Mexico moisture does not make it into West Texas, therefore a lot less precip. And the dividing line is sort of the I-35 corridor of Central Texas. It sort of waxes and wanes east or west, depending upon, the day-to-day weather variabilities. So my presentation, I'm going to cover real quick, look at some of the Texas climate divisions. So Texas is broken up into 10 different climate divisions. You can see them listed there, 1 through 10. These have been around since like the 1950s or 1960s. They've been around for a long time. It's a good way of clumping or lumping the state into, instead of looking at a single point, sort of lumping the state into, various counties that are climatologically similar in general, although there are a few outliers. You can see Climate Division 7 here includes, the Austin I-35 corridor from Austin down to San Antonio, but yet it also includes the Texas coast down there near Corpus and Rockport, et cetera. So that one's a little bit odd, but in general, the rest of these districts line up pretty well. And we'll see what time of year these districts get, or the climate divisions get most of their rainfall. So in this graph here, you can see the breakdown of the percent of the yearly precipitation by climate division, which falls in a given 3-month period. So starting the top left is December, January, February. The bottom right is November, December, January. So you can see it starting in December, running through the bottom left here, actually say April or so. These are very dry months. You're not going to have a whole lot of rainfall. So you're apt to have dryness to begin with in general. And the same thing for the last 2 or 3 months of the year, say from October through December or so. Same thing there. In general, relatively dry time of year. So we need to focus, I think, in general on the middle period here, which is starting in April, running through September. You can see that's the time of year in which most of the Texas climate divisions are green, when most of the precip occurs. You can see Climate Division 5 here in the El Paso area. They actually get about 45% of their yearly precipitation during the JAS time period, which is July, August, September. And you can see in general, though, most of the rest of the state, starting in April, running through August, is a wet time of year. So if we're going to see improvement in this drought, it's apt to be in the next month or two, through June or so, more likely than not. So you got July, August, September is the maximum precip time of year for West Texas and the Panhandle in general. And of course, South Texas has got a sort of a separate maximum the peak for Brownsville, Corpus area is actually August, September, October, and that's likely due to a contribution from tropical cyclones in that period. So, so like I said, South Texas probably absent any tropical cyclones making landfall, say in June or July, or some unexpected precip. South Texas pretty much is going to stay with little precip through July, and then the August, September, October wet period kicks in. Rest of the state, except for El Paso area, these next 3 months, the rest of April, May, and June are going to be huge as far as us getting out of this drought. This is when it should rain, and if you get rainfall during your wettest time of year, you're usually in pretty good shape. So there's a lot riding, quite honestly, these next 2 or 3 months from perspective of getting out of this drought across most of Texas. So here I've broken down the peak periods of rainfall by climate division. You can see in general, West Texas, CD5 out there, it gets about half their rainfall during July through September. CD10, August through October, they have that late summer, early fall maximum period there. East Texas, there isn't really a whole lot of variability. Pretty much, it's a very wet part of the state. They get 45, 55 inches of rainfall, pretty much stay wet year round in general. But the rest of the state, you can see in general, April through July, sort of a maximum for precip, running from Climate Division 2 here in North Texas and North Central Texas, and also including the Hill Country. So, basically, as I've been saying, the next 3 months are going to be huge. So, real quick here for Climate Division 1, that includes Amarillo, Lubbock area. You can see big pronounced maximum there from June. Well, starting in May, going through August. So next 3-4 months there are going to be huge going forward. Same thing for Lubbock area, although Lubbock seems to have a little bit of a wet spike even into September. I think the summer monsoon is big out there. That generally starts in July, runs through September. And then May and June tend to get some cold fronts coming through, which cause precipitation. But once again, key message is going to be next 3 months are huge as far as getting out of this drought. As John mentioned earlier, this drought began pretty much statewide, or at least across a lot of the state, in September of last year, and particularly in Climate Division 1 in the Texas Panhandle, their monsoonal precip cut off really quick. I think it cut off about mid to late August or so. September was unusually dry, so thus the drought definitely began out there on September 1st, roughly. CD2, which is the Childress area, Abilene. You can see that May through June peak here for both states, actually. There's your peak there in May and June. DFW Waco area, CD3, same thing, May and June. There was a little bit of a secondary peak in October, but once again, May through June, that's your sweet spot or the magic time period for getting improvement. CD4, Lufkin, Tyler area, East Texas. You can see, look at Lufkin here in the far right. You can see pretty much equal distribution of rainfall year round. El Paso, you can see the huge spike up there, July through September, associated with the monsoon. San Angelo area, CD6. I got San Angelo on the left, Fredericksburg on the right. You can see a pretty good peak here in May and June for both locations. Then that secondary peak there, September, October. Once again, May and June, huge. Austin, San Antonio area, CD7, same thing. You can see May and June again. That's going to be your time period, most likely than not, for getting improvement. If you get rain and when it's supposed to rain in May and June, you probably make it through the summer okay. If you don't, you're in a world of hurt. CD8, Houston area, you can see the pretty much, very, equitable precip year round, basically. CD9, Laredo, Cotulla area, this area has been quite dry and tends to have a little bit of a peak in May and June, but also secondary one September, October, which is probably once again associated with tropical cyclones or tropical systems. And then here's CD10, which is McAllen and Corpus. Actually, Corpus Christi, as I mentioned earlier, is actually in CD7, but I did the luxury of including it with the deep South Texas area. I took the liberty, I should say, of including with deep South Texas. You can see that big, huge peak in September. I mean, looks like almost 5.5 inches of precip, both in Corpus and the McAllen area, Brownsville area in September. So A lot riding on what happens in September down there. So as John mentioned, look at the last 30 days or so, there's been some amazing swings in precip. You know, there's been some huge winners and some huge losers, actually. North Texas, Northeast Texas is doing pretty good. They've actually had above normal rainfall the last 30 days or so. Some areas in the darker blue, they've had 200% of normal rainfall, which is good because April's one of the winter months. So I think North Texas, Northeast Texas, East Central Texas are looking pretty good in the short term. There's a few other patches here of heavier rainfall, as John mentioned, some across South Texas, some along across the Trans-Pecos. But in between, there's hill country has stayed very dry, and so has the Middle Texas coast, and of course, West Texas and the Panhandle, also very dry. So what do we have looking forward? Here's our 7-day rainfall forecast. Looks like the lighter blue areas here along the Red River, and towards Texarkana, the purple area here, actually looks like perhaps 1 to 2 inches or so the next week. So continued good news for North Central Texas, the I-20 corridor from, say, Abilene, DFW area eastward and north of that line, which is good news. We have a lot of reservoirs in that area. But you can see South Texas, pretty much near zero precip. Not much of a surprise there. This is a dry season. A little bit of precip out here in West Texas, which sorely needs it. We'll see how far west that makes it. And a little bit of a 1-inch bullseye here across the hill country, which would be much appreciated. Going out, here's a week 2 forecast from the Climate Prediction Center. And continued good news for Northeast Texas and North Central Texas. This takes us into about middle of May. You can see a continued tilt towards above normal precipitation here. Bad news for the Panhandle in West Texas, basically a tilt towards below normal precip. Here's the North American Ensemble Forecast Systems. This is their week 2 probability of 1 inch or more of rainfall. This runs from May 4th through May 11th. And you can see the north, once again, that north central northeast part of Texas has got the deep purple there is about a 40% probability. The greens are up to 60, 70%. So basically a 50 to 70% probability of 1 inch or more rainfall in week 2. Same thing, once again, north central Texas, northeast Texas. So short term, things are looking good for that area. I'd say Climate Division 3, Climate Division 4. Things looking pretty good. However, as you work your way southward and westward, not the case. Once again, deep South Texas stays dry. West Texas also stays dry. Here's a week in 3-4 outlook, and here's where things start to turn south on us. Unfortunately, you can see below normal precip there favored across most of the western half of the state, and no part of the state is favored to have above normal rainfall chances for the period from May 7 through May 20. And unfortunately, that seems to be sort of the tipping point for what looks like a pretty dire or bleak situation precip-wise for the state of Texas going into the summer. Like I said, I cannot emphasize enough how important the month of May is. So the good news is, at least for north central, northeast Texas, the first few weeks look wet, maybe even down into central Texas. Need to see about the rest of the state. This forecast here, which gets updated this coming Friday, it was issued this past Friday on the 22nd, does not look too promising. And going out beyond that, here's the outlook for May. Pretty much the entire state below normal. Obviously not good. That's, once again, generally the wettest month of the year across most of the state. And here is the seasonal outlook, May, June, July. Same thing, tilt towards below normal precip from about Wichita Falls to Del Rio westward, which is not good because that Texas Panhandle area and Lubbock area down towards Midland, it's starting to get in the wet season there. Equal chances across the rest of the state. And for the summertime, June, July, August, pretty much the same thing. If anything, the dryness tends to spread eastward and covers more of the state now, basically from about Texarkana, Shreveport area west to, or southwest, I should say, to about Laredo or so, or Eagle Pass. This is when the monsoon starts, or the summer monsoon starts in that July period. So we'll see what happens there. How to throw a temperature outlook, better or bad news here. with below normal precip being more likely than not in the summertime. It only stands to reason that the temperature forecast will also be below normal, but you'll see there is a higher probability of above normal temperatures. You can see here the darker orange. That looks like a 50% or greater probability of above normal temperatures from about Del Rio to Wichita Falls westward. So that's 50% chance of above normal, 33% chance of near normal, so 17% chance of above normal. So odds are sort of tilted at actually about 3 to 1 or greater for above normal temperatures being more likely than below normal temps across this western half of Texas. That certainly is not good news. That goes hand in glove with the forecast. A few things to look at as far as wild cards go. Tropical cyclones are always a wild card. Here is this is from the National Hurricane Center. It shows a number of named storms per 100 years. And starting in June, you can see there is about 10 to 30 named storms per 100 years. Maybe, so that'd be about what, 1 in 10 to 3 in 10 per year, 1 in 10 to 3 in 10 chance per year of getting some kind of a cyclone here along the Gulf Coast. That's for both both June and July. For August, September, you can see the tropical activity does ramp up quite a bit. And now we're up to about 30 to 50 over 100 years. So basically 1 in 3 or 1 in 2 to 1 in 3 chance of having a tropical cyclone affect the Texas coast. And these are impossible to forecast in advance. No way of knowing, but if we were able to get a tropical cyclone into a coastal area and perhaps having it move inland, it would obviously improve things immensely, as we've seen, hopefully not too immensely, as we've also seen, i.e. Hurricane Harvey in the Houston area several years ago. But in general, this is what the tropical cyclone season should look like from a climatological perspective. The NOAA will be releasing its tropical cyclone outlook on Wednesday, I believe it's May 25th. And Wednesday, May 25th is when the NOAA tropical cyclone outlook will come out for the Atlantic Basin. And the specifics are still being determined, but I think it's very safe to say, well, the forecast will be for at least near normal to above normal season, again, for multiple reasons. And this is probably one of the reasons why the probability of a triple dip La Nina, if you will. So Dr. Nielsen-Gammon showed earlier the sea surface temperatures in the the Pacific Ocean along the equator. And, we saw how, 2000, how they were below normal for starting in about September or October or so of 2021, and they've stayed, below normal through right now. Temperatures are running, about -0.5 to -0.9 degrees cooler than normal out there. So this comes in the heels of we had a pretty strong La Nina in 2020. You can see the temperatures here dip down below -1 degree Celsius. Then it warmed back up, had a repeat La Nina last year. All the models in general have been showing it to go away and revert back to normal. But in honesty, it's actually staying pretty persistent, about -0.8 to -0.9 degrees Celsius. And now it looks like more likely than not, or at least a 50% probability of us actually having a triple dip La Nina, which means that La Nina conditions will stay with us, if not through the summer and perhaps into next year, actually. The triple dip La Ninas are pretty rare. I'll touch upon that a little bit later, but you can see here, this is the most recent forecast here on the right from CPC, and they do show the probabilities of La Nina staying, above 70%, near 60% through June, July, August, and then dip down to about maybe 52, 53% during the peak of the tropical cyclone season. So based on that alone, statistically or probability-wise, we should have at least near normal to above, if not to above normal tropical cyclones in the Atlantic Basin. But you can see the probabilities of La Nina start to ramp back up a little bit into the fall. So, it is above 50%. So more likely than not, we're probably looking at this triple dip La Nina. So the big news here would be, the probably La Nina is about 50%, maybe slightly more than 50% from the summer into the fall. And La Ninas in general associated with two things when it comes to Texas or our region. Number one, increase in tropical cyclone activity. I've already covered that. And the second one is in general below normal precipitation, especially during the cool season. We've seen that too this past year. So having this triple dip La Nina, if you will, we'll see what happens this summer, but it does not bode well for next cold season. So, if we don't get the relief this summer, or certain parts of the state don't get relief this summer, should this triple dip La Nina occur or verify, looks like we're going to have another drier than normal cool season next year. And the big news here is also the fact that El Nino is generally 10% or less. So the odds of La Nina are about 5 to 1. The odds of having La Nina conditions this summer into the fall are about 5 to 1 greater than having El Nino. El Nino is usually consistent with having rainfall or above average rainfall for Texas in the cool months. So that also does not bode well for us, long term. In fact, you can see this current La Nina right now through the end of March is actually previous double dip La Ninas, year one, year two. This one right now is actually the strongest of all previous double dip La Ninas at the end of March. You can see the lighter gray lines here are previous, double dip La Ninas. We had two La Ninas in a row, and you can see where we're at right now. Actually, is basically the coldest since 1950. So I did look at those triple dip La Ninas. Like I said, there's been 3 times in the past since 1950 in which we've had La Nina conditions persistent for 3 consecutive years. The years were 54 through 56, 73 through 75, and 98 through 2000. So I looked at the May through July precip for the last year, those triple dip La Ninas, and here's what it looks like for May through July. A little bit of a tilt towards dryness across Texas, so pretty much near normal to perhaps below normal precip May through July, and that's consistent, I think, with what we're seeing in the forecast. Unfortunately, it sort of adds maybe more credence to it, although the sample size of 3 is very small and may not even be statistically significant. Here's the June, July, August precip, and this is unfortunately is even drier. It's much drier, especially for Southeast Texas and also North Central Texas. So once again, this ties in with what we're seeing in the official forecast from the Climate Prediction Center, tilt towards drier than normal conditions through the summer and also above normal temperatures. So in summary, April through June is the wettest time of the year for most of Texas. Stands to reason that if we're going to see drought improvement, it should be occurring right now in this April through June time period. Tropical cyclone activity will be huge going forward. NOAA does release its forecast on the 25th. Short term, I think North Texas, Northeast Texas looking good. I think there's been a big drop off of wildfire threat or danger in these areas thanks to the rainfall that's occurred the last 2 to 4 weeks. And looks pretty near normal to above normal going forward the next couple of weeks. So hopefully good news there for the DFW area and Northeast Texas, East Texas. El Paso, far West Texas, monsoons in July and September will pretty much determine their fate. Deep South Texas, Corpus Christi, Lower Rio Grande Valley, August through October. And elsewhere across the rest of the state, forecasts are not too optimistic for drought recovery through the summer. And that would definitely include the Hill Country and say Midland area and northward up into the Panhandle. And that's all that I have. So I'm open the floor for questions.
Great.
I'll hand it back to you, Joel.
Thank you very much, Victor. And I'll invite you to keep yourself unmuted. And John, you can unmute yourself too. We've had a few questions come in. Sorry, excuse me. The first one that I'll read is actually not a question, it's a comment from Barry Goldsmith. He says, referring to the Monday night event in the Lower Rio Grande Valley and Deep South Texas, he said, I responded to inquiries about that Monday night event. He said it was likely to be a one-off and not the same as last May when we began a nearly weekly convective slam on April 30th that continued through May 19th and effectively ended our drought and began growing our grass and our brush. So it's a comment, not a question, but I'd like you to talk about that. Was this event on Monday, this big rainfall event, was that a once-off, or is this the beginning of a wetter pattern?
Well, I would say I agree with Barry. It was pretty much a one-off. Last year was very unusual. In fact, I think last year we did a drought webinar right around this time last year, John. John and Joel did a drought webinar which concentrated on South Texas. And of course, no better way to get rainfall than to do a drought webinar. And sure enough, right on cue, it was ridiculously wet, roughly Victoria, Matagorda area, southward all the way down to the Rio Grande. Last year, and it did effectively end the drought. So, but I don't see that this year. I agree with Barry. So it was a one-off, and I would think in general, South Texas should probably see near normal to below normal precip, going forward until they get their, August, September, October wet period.
Yeah, it'll allow a little green up for a few weeks, but unfortunately, the moisture will be being depleted fairly rapidly because of that green up. So these can imply a false sense of confidence, but things start looking really good in a couple of weeks, but they then turn south fairly quickly.
Great.
Right. I think the US Drought Monitor reflects that really well. Dr. Nielsen-Gammon leads weekly calls with a lot of, folks that are very interested, or drought experts, if you will, or across the state, or folks who monitor it very closely. And, over the last 3 or 4 months, that deep South Texas area has deteriorated pretty quickly. But then they got the heavy rain this last week, so I think there'll be some improvement in this coming week's drought monitor, but we'll see what happens going forward.
Thanks to both of you. The next one I think is going to be directed at Victor. You talked about this dry line that separates the eastern third of Texas from the rest of Texas, and sometimes that shifts depending on weather patterns. The question is, has there been any recent movement in the dry line that suggests continuation or relief from the drought in West Texas? And a follow-up question to that is there a good online resource for monitoring that dry line position?
I'll take a quick stab and I'll turn it over to John. I think it's probably more of a research type question, and I'm really curious to see John's response. But there's been some, I think, anecdotal evidence that, with the persistent drought in the Southwest US, New Mexico, Arizona, et cetera, maybe, impinging into West Texas, that in turn is causing the dry line to sort of shift eastward, a little more eastward than what it usually is, or what it has been, say, in years past. And if anything, that's probably contributing to the dryness in the Texas Panhandle and West Texas. But I think that's still, it's probably anecdotal. I don't think there's any firm or hard research on that yet. But I'll turn over to John. Maybe he can enlighten me on that. So I think that dry line is not going to have any influence at all on precip for the eastern third of Texas. And for central Texas, hard to say. Probably still a bit variable depending on day-to-day, nuances. But if the dry line is shifting eastward, which there might be some evidence that it is, I'll defer to John on that. But if it is shifting eastward, I think it would bode for West Texas staying drier and perhaps being a part of that Southwest U.S. mega drought. Go ahead, John.
Okay, yeah, I look at things differently. I regard the dry line as a weather feature, sort of like a warm front or a cold front that's separating the flow of moist air from the Gulf of Mexico from drier air from the southwest. And it typically will develop when there's a storm system approaching across the Rocky Mountains, with low pressure system developing over the high plains, and that often is where severe thunderstorms will develop. There will definitely be no precipitation west of it in a given situation, and you often get severe weather to the east, but its position depends upon the particular weather pattern on a particular day. And I'm not aware of any research that's looked at the position of the dry line on typical conditions over time, over the long term, but it is likely that you can regard West Texas as being relatively arid, and East Texas as having plenty of water. And as temperatures increase, the portion of the state that era is going to be expanding.
Thanks, John. Thanks, Victor. Okay, the next one comes from Caroline. She asks, some of the lakes across Texas are well below normal. For example, Lake Travis is 10 feet below normal. It's kind of a tough one. How much rain would we need to have a drought buster across Texas?
Yeah, it's tough because it depends on individual particular reservoirs. We did pretty well. We're doing pretty well with reservoir levels because of the amount of rain we had last year during basically the first 8 months. That essentially filled up most reservoirs. An important exception of that is Lake Travis and the Highland Lakes. They didn't get any substantial runoff events, so they're quite a bit drier than they normally would be. But reservoirs in most of East Texas and most of Central Texas are running 70 to 100% of capacity. Now that changes pretty rapidly when you get west of San Antonio. Medina Lake is quite low. Most West Texas reservoirs tend to be relatively low anyway, but at this point we're also seeing Falcone Reservoir being low. So it's a good thing they got some decent rain down there recently, because that'll help cut down on irrigation use. So unfortunately, to answer the question, it's not, it's going to depend on the reservoir, and it's not the amount of rain that matters. It's how intense the rain is. Either you have a prolonged wet period so that most of the rain that falls toward the end of that is runoff, or you have an intense flood-like event where almost everything is runoff, and that can fill up a reservoir fairly quickly. You don't want it to be particularly destructive. The problem with the long-term rain filling up the reservoir is everything's wet anyway, so you don't actually need the water by the time the reservoir is full.
Victor, do you have anything to add to that?
Yeah, real quick, for the great website to look at is Water Data for Texas. It's Texas Water Development Board website, and I just took a quick peek at it. And all the reservoirs in North Texas and Northeast Texas are doing fine, 70, 80% or more of normal, capacity. But like John said, once you get, into the hill country, West Texas, that's when things start dropping off. Not too uncommon, like John said, to see that. And the inflows have been really low. Talked to some hydrologists for the Colorado River Authority. Their inflows go way out towards Junction area and out in the hill country, and they've had very low inflows so far this year. So that would account for Lake Travis being so. You don't really need the rainfall right over the reservoir per se. You need it, upstream, in the river basin. And with the hill country being as dry as it has been, I can see Lake Travis being dry. And I think going forward, it's going to remain to be a challenge, because the hill country, everything we're looking at, it is one of the areas that's in the most significant drought right now. And prognosis going forward, at least at this time, doesn't seem too good. But if it's going to fill up, once again, I think May, June is your time period for doing that. If it still works out right now or even lower, when July 1st rolls around, that's not a good sign.
Thank you. I'm going to move on to the next question. This comes from Bob. He asks, he's pointing out, first of all, that the influence of La Nina in Texas weather typically wanes in the summer months. And I may interject there. I'm not sure if that's an influence that's waning or the actual La Nina event that's waning, but usually we don't talk much about La Nina during the summer across the Southwest. With that in mind, what is the mechanism that is expected to keep Texas so dry this summer? So I might interpret that by saying, what else is the seasonal climate model picking up on that's really going for this increased dry pattern?
Well, I think some of the the longer range forecast models, the NWS has a coupled forecast system, CFS version 2. It's both a atmospheric and ocean coupled weather forecast system. I believe the CFS V2 has been showing a pretty strong tendency for below normal precip across Texas into the summer. And I think perhaps some of the other better models as well, perhaps a European model. But Bob is correct in that the influence of La Nina is pretty minimal during the summertime. And so that's why, I don't know, I did the analogs with the triple dip La Ninas and, what does year 3 look like? And there's only 3 episodes of it, so it's a very small statistical sample. But you can see it was, tilted towards dryness. And I think there's a lot more indicators in general tilted towards dryness than there is towards wetness. Although, once again, the big kicker, one tropical system sometime between June and September, June and October, could quickly change that.
Yeah, there's one other factor that the Climate Prediction Center has also latched on to, and that's the fact that in spring and summer, a lot of the moisture that we get comes from thunderstorms, and a lot of the moisture and energy that feeds that comes from moisture that's already in the ground. We call it a feedback mechanism. And so when we go into late spring and summer with dry conditions, that makes it more likely that we'll have fewer pop-up thunderstorms developing, and the dry conditions will actually persist because of that. We start off dry, and that makes it more likely we remain dry.
Great point. Thanks, John. Thanks, Victor. We've got time for just one last question. And this is sort of a broad brush question. We've been in drought since about September. Looking forward, it's continuing to dry. Which industries are usually hardest hit by a sustained drought like this?
Well, agriculture is the primary impact from short-term drought. Winter wheat, more than 80% of the winter wheat crop in the state is rated at poor to very poor at this point. With the normal harvest season coming up in a couple months, it's going to be very hard to get much recovery out of that. And even irrigated crops cost money to irrigate, and so the drier it is, the more money you end up spending, and eventually it becomes a money-losing proposition. Ranchers as well, having had difficulty during the winter in many parts of the state, having to continue supplemental feeding, waiting for the warm season crops to get going. The fact that it was cool this spring and late winter didn't help much, because it gave those grasses a late start anyhow once they did get some moisture. The other big impact we've seen so far is with wildfires, because again, the wet conditions during much of last year meant lots of grasses grew, and then dry since then meant they dried out, and there's plenty of fuel in the ground. And until the landscape greens up with hopefully some decent rainfall in the next couple of months, that wildfire risk will persist until we start seeing the winds die down later in the spring.
Thanks for that summary, John. I think let's just hope for some rain. There was a bit of rain in the 7-day forecast that Victor showed. Let's hope that that's enough. I'd like to wrap up our webinar there. A big thank you from me to both of you for taking your time and sharing your expertise about Texas weather and climate with us today. Just a reminder for those who have attended, this webinar has been recorded, and I'll make the recording available. I'll be sending it out in an email here in the next 2 or 3 days, hopefully sooner than later, but we'll see. And that concludes today's webinar. I hope you all stay safe, and I hope you get some rain. Thanks. Bye-bye.
Thank you, Joel.